Hello everyone, this is Matteo, and this week I've been busy developing a new extension for you. So between all the new technologies, I decided to implement a PuLID, or maybe it is PuLID, but anyway, let's see how it works and how it compares to the other models. So apparently PuLID stands for Pure Enlightening ID. And in fact, the demo makes use of a 4-step lightning model. I made some tests and it surely works, but for best results, in my opinion, it's better to use at least an 8-step model. So here I have DreamShaper XL Lightning. I need an apply PuLID node and connect the model pipeline. Then I can drag the PuLID input and select PuLID model loader, the same for the EVA clip and face analysis. As you can see, PuLID is basically an IP adapter model that takes the embeds from inside face and EVA clip instead of the usual Lion clip vision. As reference, I'm using the Mona Lisa because why not? And I'm lowering the weight to say 0.75. The prompt is close-up of a woman with fox ears and white hair in winter. The K-sampler is configured as DreamShaper recommendation, 8-step, and DPM++ SDE sampler. Okay, let's see how it goes. And here we have our foxy Mona Lisa. I'm sure Leonardo is swearing at me from the afterlife. Now, if I zoom in, you'll see that the face is a bit blurry and not completely formed. What I've noticed is that PuLID really takes advantage from a second pass. So let me add an end latent upscale real quick. I duplicate the K-sampler. Remember, with Shift-Control-V, you'll get the node with all the pipe connection filled for you. I change the seed, set the denoise to 0.5, then I need the VE decode and the preview. If I generate now, I get a more defined face and also the colors are more uniform with the rest of the image. There's still a lot of noise, but that is because we are using a painting as reference. Let me try with a better image. I'm also adding listening to music to try to add more details. And here we are. We also got an actual hand with the right number of fingers. So how do we know how close this image is to the reference ID? Well, to help us with that, I have the face embeds distance node. For the face analysis model, I use dlib, that is nice and light. Then I connect my generation and the reference. As metric, I'm choosing cosine, that in this instance should be the most reliable. This node will give us a numerical proximity between the two images. So in this case, I have a distance of 0.44. The lower the distance, the better. A value of 1 means that they are completely different people. 0.5 is generally pretty good. To improve our score, we can try to send multiple reference images. Let me duplicate the load image node and I'm selecting 2 more pictures of Ferguson. To merge them, I use an image batch multiple node, and you may know this already, but all batch nodes resize the images to the dimension of the first one in the batch. This is very important to understand because if the first image is very small or in an extreme aspect ratio compared to the others, you'll get undesired results. If I put a preview here, you can see that the second image has been cropped closer to the face. If I swap the first and the second image, now all pictures are in portrait mode. This is also the reason why you can choose the scaling algorithm. For example, for pixel art, nearest exact might be a better option. Okay, now that we have all the images together, I can send them to the PuLID and to the face analysis, and I can generate. So to my eyes, the image looks slightly better, but the distance actually increased. So let's try to understand why. I'm bringing the images closer to the end result, and I'm going to check the distance of each picture individually. So the distance of the first is 0.59, the second 0.55, and the third 0.93, which is very bad and it's totally driving the model off. Let me try to replace it with this other one and generate again. And now it's much better. The distance is 0.403, which is better than the starting 0.449. Now let me check the likeliness of the first generation and not the upscaled one. The distance is now 0.36, that is noticeably better than the upscaled. That's because these face models are trained at a very specific resolution and they don't perform well when upscaling. So let's try to get some blood out of this stone. First of all, I need to cut out the face so we can concentrate only on that. You can use any face bounding box node, but we have already loaded dlib, so I'm using the face bounding box node that connects to the model that we already have. I connect the first generation to it, set a padding of 0.2 and check the result. Okay, these will be too close, but I'm going to give it a try anyway. I need an image resize and bring it to 1024. That is a very comfortable resolution for SDXL. I set the height to 0, select keep proportion and change the interpolation to Lanczos. Now I connect the face analysis to the cropped face and check the result. So our baseline is 0.365. Now I'm removing the NN upscale and I'm going to reuse the second K-sampler for the face detailer. To get better results, I'm adding an helper model. So I need an IP adapter, the unified loader with a plus face model, and connect the pipelines. Plus face like the face cut very close to the frame, so I'm getting this reference over here and crop it to 512 by 512 in the center. Let me preview this. Okay, perfect. I'm also passing it through a prep image for clip vision and I can finally connect it to the IP adapter. I'm trying with a weight of 0.5 and I'm also lowering the end at value to 0.9. Remember that we are dealing with a lightning checkpoint and we cannot skip too many steps. 0.9 will basically only skip the last one, but it's a good 12% of the whole generation. Okay, the noise 0.35 should be enough. Now I need to send the face to the latent space, connect the VEI, and then to the K-sampler. Finally, I'm duplicating a face analysis, connect the new generation, and check the result. Let me put the two images close together. So the second pass has more details, but the likeliness is worse. That's because we are too close and we probably would need a better prompting for such a close-up. I can simply go a little further away, setting the padding percent to 0.5 and try again. And yeah, in fact now the face is nicely detailed and we are still very close to the reference. Okay, now all left to do is to put the face back over the original generation. Again, there are many ways to do that. The easiest is probably with clipseg, but you can use segment anything or whatever. I connect the image, write face in the prompt, and check the mask with a preview. Okay, perfect. Now I need to scale down the face to the original size. I need an image resize node, convert width and height to an input, and connect them to the width and height in the face bounding box node that very gracefully saved the original size of the cropped image. As always, I'm selecting Lanczos in the interpolation, and I'm ready for the final composition. I need an image composite masked. In the destination, I connect the image from the first pass. In the source, the scaled down second pass. And in the mask, the result of the clipseg. Now I need to position the face back in the original spot. I convert X and Y to an input and go back to our friendly face bounding box node that also saved the X and Y position. And here we go. I can take another face embed distance, connect the image and add a preview. And the result is, drumroll, 0.378 versus 0.4 of the original generation. So we actually improved the likeliness, but now the face looks a little photoshopped. So I'm going to add a very light upscale with a third pass. You can upscale with whatever method you prefer. This time I'm doing a simple upscale image by 1.5. Send the image to the latent space, connect the VEI, duplicate the original K-sampler, increase the seed, set the denoise to 0.3, then I duplicate another face analysis, connect the image and the preview. And that's it. We lost a little likeliness, but the overall image is very good. Okay, this is what we can do with the official implementation. But you know that I'm never happy with the defaults, so I baked for you an apply PuLID advanced node. This one really squeezes every last bit out of the face model. By default, it is set to projection ortho v2 and fidelity 8. That is the same as the method fidelity of the standard node. On top of that, we also have a noise option. Let me move all the pipes to the new node. And I'm disabling all the additional generations except for this one that will tell us if anything actually improves. Now, if I set the weight to 0.75, nothing should change. Yes, we are still at 376. To try to get better result, I'm lowering the fidelity value. The lower the number, the closer we are to the reference. So I'm gonna try with 4 instead of 8. And I'm also adding some negative noise. If I generate now, I should get a little improvement. Oh wow, that is more than a little. This is actually creepy good. Okay, I'll leave this to you now. You can experiment with various options and maybe you can come up with an even better configuration. At the moment, the features in the advanced node are exclusive to ComfyUI user. Not even the official implementation has them, but as always, all my code is free and open source, so anyone can use it. One last thing before moving to the next topic, these tools are getting better and better. I'm using photos of celebrities because they are public figures and it's easy to find good quality pictures of them, but only for educational purposes. Don't be a dick and only use photos with the person's consent. Okay, next we are going to talk about style transfer and attention masking. So I have this workflow that generates this kind of pictures. I can add an IP adapter, the unified loader with a plus model, connect the pipelines, and as weight type, I select style transfer. For the style reference, I'm using this painting. Let's see what happens. This is cool. Okay, let me move the IP adapter and the K-sampler away, and I'm creating a new PuLID node. I need to connect the model pipeline and the reference. I can think of a better counterpart for the Mona Lisa than Botticelli's Venus. Now I'm preparing the mask. I create a black solid mask the same size of the latent, then a second mask, this time white, half the horizontal size. I merge them together with the mask composite, operation add, and connect it to the first PuLID. Let me disable the final generation and put a preview here to see what we've done. Okay, this is the mask for Lisa. Now I can simply invert it and send it to the second PuLID for Venus. I need to change the prompt to close-up of two women on the streets of Neo Tokyo. Let's see. Now I know what you're gonna ask. Can I use two different styles for each person? Well, yes, of course you can, but you need all the VRAM. So I need to duplicate the IP adapter and connect the model pipeline. Then the first mask goes to the first IP adapter and the second to the second. As reference, I'm using this illustration and QPrompt. And there you have it, two ideas, two styles. And you can also use extremely different styles like this anime and this line art. If the checkpoint is good enough, you will always get great results. We lost a little of the likeliness. We can try to fix that by lowering the style weight and increasing the PuLID weight. Anyway, attention masking is now supported in PuLID. Remember to upgrade because it's a new feature I just added. Okay, it's time to make a comparison between the face models that we have available today. I'm giving you the spoiler right away. Overall, they are not great and there's no clear winner. Also remember that with the exclusion of PhotoMaker, they are all based on Insight Face that requires an hefty license for commercial use. So let's start with PuLID. In the description, I asked for a cyberpunk woman with purple hair. The prompt is followed pretty well. I have some cyberpunk elements and we've got purple hair. The likeliness is decent, but the skin lacks details. And as we noticed before, PuLID really needs a second pass. Next, FaceID. The likeliness is pretty good and we have very nice skin details. The image is less blurry, but the prompt is basically not followed. To improve that, I would need to lower the weight and doing so losing likeliness. Or I can try to use attention masking on just the face. If I take this image as reference and select the face with the mask editor, I can use it as attention mask and try to generate again. The result is now closer to the prompt and we haven't lost much of the likeliness. If I add a control net to also fix the pose, the result would be even better. Next, PhotoMaker. Unfortunately, there's not much to say. The image quality is very good, but the likeliness too loose. This can be improved a little, but not in a satisfactory way. Then we have FaceID Unnorm Portrait. This is a weird cookie. It's generally very good. You can get nice details and the prompt is followed pretty well. Likeliness is not great, but can be improved with plus face and attention masking. So overall, it's a good starting point that needs help to get where you want it. Last one is InstantID. This is a bit of an unfair comparison because InstantID is also a control net. The pose by default is taken from the original reference, so of course the likeliness will be better. But if I take one of the composition we did with one of the other models and send it to the pose reference, you'll notice that at the end the likeliness is the same as the other models. But anyway, out of the box it is a very good model and prompt is generally followed very well. The image unfortunately is very burnt and the result a little video gamey. But I'm using a lightning model and with a different checkpoint we can probably get more natural results. So what's the conclusion? Well, none of the face models that we have today is good enough for a one-shot generation. All of them need help from a control net or a second pass. As of today, FaceID with a control net and attention masking is probably the best for realistic results. If you need more freedom with the prompt and the style, PuLID or FaceID Portrait Unnorm are really good. InstantID is overall a good option both for likeliness and styling, but it's pretty heavy and needs to be tamed to avoid overburning. So here you have it. I hope you now have all the information you need to make an educated decision. I'm leaving you by saying that I'm checking open alternatives to the inside face models that can be also used in commercial applications. Apart from the technical difficulties, there are some ethical and legal concerns to consider, and I believe that is the reason why we don't see more of these models around. Anyway, more on this soon. For today, that's all. See you next time. Ciao.